So for this lecture, I'm just going to be talking about assignment 8, and I'm going to be showing recursion because this assignment very heavily uses recursion. Also, I'm going to show like doing a try catch block. So I'm going to be using a few different recursive functions just to show you how to write a recursive function. So I'm going to be starting with Fibonacci because Fibonacci is pretty easy. So Fibonacci sequence is just for any number k, it is the sum of that number and the sum of every number before it. So for example, Fibonacci for 5 is 1 plus 2 plus 3 plus 4 plus 5. The Fibonacci for 4 is 1 plus 2 plus 3 plus 4. Fibonacci for 3 is 1 plus 2 plus 3. And if you can already see where this is going, the Fibonacci number for 5 can also be seen as 5 plus this. And this is just the Fibonacci sequence for 4. And the Fibonacci sequence for 4 can be seen as 4 plus this. And all of this is the Fibonacci sequence for 3. So what I'm getting at is the Fibonacci sequence for any number can be seen as that number plus the Fibonacci sequence for the number 1 less than it. And that in turn means that that Fibonacci number can also be seen as what I'm basically getting at is that Fibonacci is recursive in the most simplistic sense. Fibonacci 5 is 5 plus Fibonacci 4, and Fibonacci 4 is 4 plus Fibonacci 3, Fibonacci 3, etc., etc. And it is the most basic, simple, easy, like recursive program to use to demonstrate. So the important thing about recursive functions, before we do anything, is that recursive functions have a base case. And a base case is, depending on what the value of n is, if n is the base case, then that means that you can just return something immediately. So, for example, the base case for a Fibonacci sequence is that x is 1 or 0. Because the Fibonacci number for 1 is just 1. And the Fibonacci number for 0 it's just 0. So those are the base cases. All right, so we have the base cases down. All right, What if it's not the base case? What if this isn't? What if this is 5 or 4 or 3 or whatever? We've already established that the recursive definition of a Fibonacci number is the number itself plus the previous Fibonacci number. So the Fibonacci number for x, no matter what x is x plus Fibonacci x minus 1. Is everyone following along? I know this is incredibly simple, but recursive functions can get really complicated. So I just want to make sure that everyone understands. All right. I know that this is all really like dead simple, but I really want to explain recursion to you in a really simplistic way just to show you the basics of how it works in programming. So that way when you do the assignment and I say like, oh, this is the base case, you know, or this is this case, you know what that means. Do that so it will return. I think I might have messed up. I think I might have gotten Fibonacci wrong. I've gotten Fibonacci completely wrong. All right, so the Fibonacci sequence for a number is actually even more recursive than I remembered being. I was thinking of factorial. Fibonacci for any number k equals specifically the Fibonacci number for the previous number plus the Fibonacci number of the number before that one. All right. So now that I have the correct Fibonacci number, I know that this seems incredibly specific and you're wondering what good a Fibonacci number is, but usually really, really simple recursive problems are often only useful just to show off recursion. Let me show you how to do factorial. So factorial is equal to number times every number that comes before it. So it's this 5 times every number that comes before 5. And once again, this can also be defined recursively. So the factorial of 4 can be viewed as 4 times the factorial of the number from before it. In other words, factorial of k equals k times factorial of k minus 1. Because this can all be... This is another recursive definition. So the base case is x is... It's the same for the Fibonacci number. Base case for x is 1 or 0. Else you want to return x times factorial of x minus 1. All right. And 5 factorial is 120, because it's recursively defined as the number times the factorial of the number before it. Now, for a try-catch block, you already had to do one for assignment 7, so you're familiar with it. But sometimes you can catch multiple things. So all right, so in this little try-catch block, I have 3 different throws. And each throw is a different type. So this throw is throwing a string. This throw is throwing x, which is an int. And this one is throwing a char. So if I wanted to catch this one, then I would have a catch down here where the type is a string. I'm catching a string. Because to catch something we throw, all we need to do is match the type. And you can string catches together, and it'll catch all of these so long as the types match.
Daniel, I have a question.
Sure.
Why would you... Is this just kind of demonstrating functionality? Because when you throw, aren't you printing it anyway?
Not exactly. So throw literally just means throw it. like just throw it, and the catch literally is saying like catch this here. Um, for example, I could say, all right, catch this number. But then I could say, don't print here, return from the function. I could, for example, get rid of this. I could say like return, and it would just exit. It would be like, all right, exit, because this wasn't supposed to happen. So just return. I'm merely making everything print just to show like how to use it. Like I'm mainly trying to give you kind of a reference that you can go back to for how to do multiple throws and multiple catches. And let's say we wanted to catch this final one. Well, we just make it be a care.
Is it possible to catch multiple objects at once? Or not objects, variables at once?
I'm honestly not exactly sure. I've never done it before. I'm going to look that one up. That's a very good question. Thank you. You can't catch multiple in one block. You can only catch one. And usually, when you throw an error, usually you're just kind of checking for one thing. But anyway, this is just a really simplistic, basic try-catch block, just trying to show you how it would work. So we got two numbers, x and y, and these if statements check the value of x and y. I think I am missing a bracket somewhere. Oh. Whoops. If you want to catch a string, you need to predefine that string and then throw the actual string variable. I'm glad that I made that mistake because now I can specifically point it out to you guys.
Hey, Daniel. Another quick question. Sorry so many.
That's fine. Don't worry.
What is the scope of a throw? Like, does the catch block have to be directly after the try?
Yes, the catch block has to be directly after the try. Because when you do a try block, you want to catch the error immediately. You want to deal with it right then, not necessarily do something afterwards. But anyway, also these questions are really, really good. There's not much specifically to teach about how to use a try-catch block. So any misconceptions or anything you don't understand about this or recursion are great while we're still here in the IDE and I'm still programming. But following what the program did, so it got to here, and it compared x to y, sees that x is less than y. So it throws the string, and because this catch is trying to catch a string, it catches the string and then runs this code. Let's say I switch this around. Whoop. Run it again. So with these two numbers like this, it checks it here, finds that x is not less than y, checks it again here, x is less or x is greater than y, and then it throws x, which is an integer. And so this catch statement, which is trying to catch an integer, catches it and then runs this code. It completely skips over this catch because this catch wants a string. If I make them equal, so now that they're equal, when it gets down to this if statement, it says, yes, they do match, so throw a character. And the final catch statement is waiting for a character. And so it runs this code. Are there any questions anyone has about recursion or try-catch before I go to the slides and start talking about the assignment?
If we were to throw, or if we needed to catch multiple variables of the same type, would we throw something else and just print it? You kind of understand what I'm saying? Like catching two different strings for two different exceptions.
Yes, you could. So let me try to... So let's say, for example, so this one prints a char. I'll change it to throw that string. So this one is now throwing a string. X and Y are equal, so do that. So even though these are both throwing two different strings, this one caught both of them. Because specifically it is looking for a string to catch. So it doesn't matter if we have one throw that's throwing a string or if we have like 10 throws all throwing different strings. Whatever you throw up here, the catch that matches the type is the one that will catch it. And it will always go like going down. So let's say you have like an int up here. Let's say this was like int. You're trying to catch an int. But down here you have a double. Like if that... Like if a type up here can also catch a type down here, it will catch it up here. It's just in this instance, none of these conflict. Any more questions before I go to the actual slides? All right. All right. So for move in the object, I think before I actually talk over the slides, I'm basically going to do a brief overview of the assignments so that you know what these kind of mean in context. So for this assignment, basically what you're coding is kind of a game where two animals in a forest move down a path and then they might meet and one might eat the other. It's basically kind of a rock, paper, scissors thing. Where there is a grid that is dynamically allocated, and an animal will start somewhere and it will move down a preset path, and another animal will start somewhere else and it will move down a preset path. And if they meet, depending on what the two animals are, one will eat the other. And the move function is what actually moves the animal through the forest, because the grid is supposed to be a forest. So in the grid, anything that has an X in it is an empty space. Let's see, letter X. So this means that there's nothing there. And when you run this, you want to run it in a try-catch block, because there are errors that you want to catch and handle. So, also, by the way, when I talk about the X and Y position, each object has an object dot position. Actually, it's specifically called current position. And current position has a dot X or a dot Y. So you can have object.currentPosition.x and .y. But that's a lot to write, so when I write in here, I'm just going to use X or Y, and you know that I'm talking about the X and Y of whatever the object's current position is. So the first thing you want to check if the X and Y is outside of the forest. If the X is out of here, or if the Y is out here, then that's an error. And you want to throw this message, where name of the animal is, of course, replaced with the actual name of the animal. So if the current XY coordinate, and in this case, in this assignment, X and Y are not flipped. So this is actually the X-axis, and this is actually the Y-axis this time. If the X and Y coordinate of the forest is X, so this grid, I need to specify, in the game, is represented using a 2D array of strings. So each of these is a string. So if the current string is an X, that means there's nothing there. That means this is supposed to be empty. And this should be overwritten with whatever the character of the animal is. Else, the symbol of the animal should be added to the end, meaning it should be concatenated. I'll show what that means in a second. Then you use path.at, because the path is a member of the object and the path is a string of directions. So it's like up, down, left, right, etc. And it determines where this thing moves. So use the path to get the next direction, and then you should print name of animal is moving. And there are two catches you want to have for this. One to catch an out of range error, which is a special type of error that is part of C++ for anytime a string goes out of range and you want to catch a string message. Each should print a message and return from the function. And the different messages are, they're in the PDF and they are in the example output. And if all of this runs with no errors, you want to set the current position of the animal which is another function. There is a set current position. And it takes a char. And then you want to move again. Meaning you want to move the animal to the next step after start. Any questions about this function? All right. So I'm just going to kind of walk you through moving an animal through the forest just to show you what just so you get an idea what's supposed to be happening. So this character, the animal moves here. So there's an X there, so we draw its character there. Then it moves to the left, to the right again. And there's just an X there, so we write the animal symbol. And then finally it moves down. And it's the end of its path. And we write the character there. Now I'm going to randomly place another animal on the board. Place an animal here. There's an X there, so we overwrite it. This goes down. There's an X here, so we overwrite it. Let's say this animal moves to the right. There's an X in this part of the grid, so we change the string to be whatever the animal's character is. Now let's say it moves up. Well, there isn't an X there. There's the character for another animal, so we concatenate it. There is one string that is both of these characters there at the same time. So if two animals are in the same spot, both of their characters should be in that string. Does everyone understand, or does everyone understand this kind of decently?
So when you move your animal, you leave the old symbols where they were, or you change those back to X's?
You leave the symbols where they are because at some point the grid gets printed, and when the grid is printed, you want to show the full path that the animal took. So let's say that this animal moved up here. After that, you want to show the full path that that both of these animals took, even at parts where they met. So first off, this function should not be concerned with checking if they meet. That happens later. This is just putting the animals in the forest and then moving them and then leaving the trail of where they went.
Gotcha.
All right. So the forest is the class for the actual forest itself, and it is a template class. So the types that it holds can change. That uses templates. And the constructor takes 4 arguments. It takes the rows, the number of rows, the number of columns, and the types, type 1 and type 2. These are the 2 animals that will be in the forest. So you just set the values of rows and columns. Don't do error checking. Just assume that the rows and columns will be valid. allocate the grid to a new 2D array of strings, and set each index to the string x. The forest, when it's the grid, when it's initialized, should just be all x's. And then you want to set object 1 and object 2, which are both member objects of the forest class, to a new T1 and a new T2. Because object 1 is one animal in the forest, and object 2 is the other animal. And when you set them to a new T1 and a new T2, when you call the constructor, when setting it to a new whatever type, you want to use these two arguments to pass information to the constructor for these two objects. Now for the display forest, this is going to be a recursive function. So this is a function that will, much like move, this and move are both recursive functions. And it is passed two variables, the current row and the current column, that are going to be printed. And when display forest starts, when it is first called in main, it will be passed 0 for the row and 0 for the column. So if the current column equals the size of the columns, meaning you've gone out range, reset column back to 0 and increment row, because you've hit the edge column. So you want to say, all right, we'll fit this edge column, go back here, but also go down one row. So we start here, and then repeat. And you want to print a new line to reflect the fact that you're going to another line. If row equals rows, which means that we've hit this row, then just return 0. Which means we're done and we need to go all the way back out. And if when all this is done, you want to print the current row and column of the grid and a tab, because you want each of these letters to be separated by one tab. And then you want to display the next column in the grid. Does everyone understand this so far? All right. So do they meet is a function. This is where we actually check if two animals meet and if one eats the other. And all this needs to check is if two animals meet. The main function, or the simulate function of forest, will check which animal eats the other. But once again, you want to use this in a try-catch block, and this is also recursive. So you want to get the current position of object 1 and object 2. And the first thing you want to check is if they share the same, if the positions share the same x and the same y value, return true. Meaning they're at the same spot in the grid. So they've met. If either position is off the grid, then return false, because that meant one animal just left the forest. And then after both of those checks, you want to use the path to get the next position. So the same way you did this in move is how you would do it here. And after that, you'd want to check if they meet again in the step after next. So next +1. And when you check again, you want to save that return value because you need to return that at the end of the function. So you don't return here. Just check, do they meet in the next step, and then save it to a variable. For this try catch block, you want to catch an out of range because the path is a string. So if you go off path, the path string will throw an out of range exception. And if you catch an out of range exception, just return false. Because that means we've gone through both paths entirely and they did not meet. And after that, if none of these have returned, then you want to return the value that you saved this step. Everyone kind of understand this so far?
I have a question, Daniel. So when you put at the top, use a try catch block, are you referring to the catch and out of range, or is it different, a whole different try catch block?
Do you mean is this try catch block here supposed to throw and catch an out of range expression?
Yes.
Yes, but the out of range expression, you don't have to throw that yourself. The .at function, which you will use to get the next character in the path, this throws an out of range expression automatically if you try to get a character that's outside of the string.
Okay, gotcha. That makes sense. Thank you.
All right. All right, so I'm briefly going to talk about problem 1 and problem 2. So problem 1, by the way, these are both also recursive functions. But these are really, really simplistic, and honestly, the algorithm for these would be kind of just the actual code itself. So I've decided, for this one, I'm just giving you hints to figure out each problem. Now, rest assured, problem 1 and problem 2 are both relatively simple to figure out. So for problem 1, you have some kind of array. 1, 20, 140. And you want to find some number that is you want to find a number that's the biggest number that is less than k. And you have L, which starts at the lowest index, and you have, I think, U, which is the upper index. So L starts at the bottom, and U is the top index. And you want to go through the array, and for each number, you want to check, is this the current, is this number our current biggest number that's less than k? So, but also with the added bonus that if none of these are less than k, if k is smaller than every number here, return -1. So walking through this example, we started at 1. We check is 1 less than k. Yes, it is. So we move L forward, and our current return is 1. Say, all right, is 20 greater than 1 and less than 30? Well, it is. So we're not returning 1 anymore, we're returning 20. So then we move L up. All right, is this greater than 20 and less than 30? No, it's bigger than 30. So we don't care about this. We want to move L up. All right, is this less than 20? Or is this greater than 20 and less than 30? Well, yes, it is. So now we want to return 23. And finally, we go to when L and U match, and that's our final check. We say, all right, is this final number greater than 23 and less than 30? No, it's less than 23. So the number we would return for this list is 23. And
quick question. What are L and U? Is that just the lowest value in the array? Or is it at place 0? I'm not too sure.
L is literally index 0. It is literally index 0. And let me, for example, let me show you another way this could be done. So we have L and we have U. And U is the index of the first number. L is the index of the first number because it's low. U is the index of the highest number because it's up. Now we could instead do this. All right, well, let's move L here. Then 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 let's move L outside the array. And if we're here, since we're outside, we'll just start with -1 and then go backwards and then compare each of these. Is each of these greater than -1, but also less than k? And some hints is each value in the array is positive. So these are never going to be 0 or a negative number. They're always going to be greater than 0. And you can use the lowest index as the thing that recurses you through the function. For problem 2, the function is passed some kind of string. And you're passed the string and also the indexes left and right. And what you want to do is you want to recursively swap the string. What that means is that for each step, you take L and R and you swap them. So you swap the 2, then you move them forward. You swap them again, and then you move them forward again. Swap them again. And then when they cross, when left and right cross, that means the whole string has been swapped. So that means that once all is said and done, string is now geniertz. Or like hello would become ole because the string would be reversed. Does everyone understand what these two problems are?
I think I understand the problems, but they're not related to the forest and object issue, right?
Not at all. These are each problem 1 and problem 2 are both separate C++ files.
Okay, awesome.
All right. So that's everything I have for the video. Any final questions about anything I've talked about so far?
Yeah, I just have one final question about the forest constructor. So, when we're setting object 1 to new T1, just to make sure we're including the brackets and the size of the rows, right?
So when you say include the brackets, that means the constructor, like parentheses, right?
Yes.
Yes. When you set it to a new T1, you want to use the constructor parentheses. Because you're setting it to a new T1 that you are specifically calling the constructor on.
Oh, okay. All right, that makes sense. Thank you.
All right. Any more questions about anything that I've talked about so far in the past hour?
I have a question going back to the move function and the throwing out of range. Or catching out of range, something like that.
All right.
How are we meant to make move recursive, right? Because recursive is supposed to have the base case, so when does it end?
So that's what the catches are for. The catches in this case are the base case. Because the catch is... the one catch is that this goes out of range. So the path string at start is outside of the string. So this will throw this error. And the other base case is that X or Y is outside of the forest, meaning that X is outside of the rows or Y is outside of the columns. And that's when you throw name the animals out of forest and then catch it down here. This is essentially the two base cases just turned into a try-catch block.
The out of range catch, what type is that?
The type is literally called out of range. It inherits from a different type called exception, which is a special C++ type made specifically for catching errors.
Okay.
Any more questions about anything that I've talked about so far? Anything at all. If there's something I talked about way back in the beginning when I was programming that you have any questions about, feel free to ask. All right. I'm going to stop the recording. I'm going to upload the video and post it on the assignment page. I will be available until 4 o'clock today to answer any questions and tickets. But have a nice day. And I hope this lecture was able to help you.